Good Hello, Kaushik. Good afternoon.
गुड आफ्टरनून सर।
कौशिक, कल का सेशन अटेंड किया था क्या?
हाँ, कल वो जो क्वेश्चन भेजा गया था उसी का वो डिस्कशन किया था उसमें।
कौन से क्वेश्चंस थे?
ऑपरेशन ऑफ सेंट्रीफ्यूगल पंप, कंस्ट्रक्शन, वाटर इंस्पेक्शन, how NPSH,
एनपीएस।
okay. Those kind of question are discussing.
ठीक है, फिर मैं लेक्चर रिकॉर्डिंग चेक देख लूंगा, अपलोड हो जाएगा।
नया टॉपिक कुछ नहीं था जो पढ़ाया गया था, बस उसी का कुछ रिलेटेड क्वेश्चन जो आया है।
हम्म, ठीक है, थैंक यू।
Hello, good evening, good afternoon, all. So, can you hear me, Kaushik, Raghav?
Sir, lot of disturbance is from your side, background.
Okay, now you can hear me now.
It's much better, sir.
Sir,
Okay.
sir, please don't keep this mic in front of your mouth. You just let as it is, so noise will not come.
Okay. Now
And
it
now
is
it
better.
is okay. And now it is okay. Don't keep the mic in front of the mouth. Sir. It will create the noise.
Okay.
Keep it to a certain distance, then it will be okay.
Okay. Now it will be better.
Now is better, sir.
Okay. Acha, so today I will just discuss about, yes, actually yesterday Raghav was not there. So Raghav, yesterday that class was uploaded. I think Dilip, he was uploaded the class. He will upload.
Yes, sir.
Hmm. So because yesterday we are just talking about some questions
Okay.
of your centrifugal pumps, mostly some questions that was discussed. That yesterday there is one question I was discussing, no, that how you can measure the performance of the centrifugal pump. Just I want to say one thing. This is actually, you can not only for the centrifugal pump, any pump if they will ask you, na, this is another method by which you can give the answer. That the pump capacity. In your every pump, there is a pump side or motor side, there is one template. So in the template, there is written that the pump capacity, what is the pump capacity. So maybe 6 meter cube per hour or maybe 3 meter cube per hour, like that it is showing. So when they actually were measuring the performance or your efficiency, you can measure. So that time you check that how much, suppose you are discharging your sludge. So by the pump, sludge pump, where in your tank maybe 6 meter cube or 7 meter cube or 10 meter cube, whatever the quantity in remain in your tank. So according to the capacity of the pump, you have to calculate. So we require this much of the timing. So maybe 1.5 hour, we are discharging the 8 meter cube or 10 meter cube of your tank. We are discharged. So as per the rated capacity, which is written in your template of your pump, if pump provide almost same to same, suppose instead of 6 meter cube per hour, it is given the 5.5 meter cube or maybe 4 meter cube per hour, then it is okay. But if it is dropped down, maybe suppose instead of 6 meter cube per hour, it is going around the 2 meter cube per hour, then there will be the efficiency or the measure or the capacity of the pump, it will drop, or the performance of pump, it can be dropped. So basically that question, the surveyor, I think there is a two ways. One answer you can give that from the for the centrifugal pump, that we can check it from the characteristic curve of the centrifugal pump, from where we get the head. According to the head, we can get the discharge, we can get the efficiency, we can get the php, we can get the npsh value. So from there we can get one idea, from there the best efficiency point. So according to that, we can judge the pump centrifugal pump capacity or performance, how much it will give. Or otherwise, from the template, whatever it is written, that it what is the capacity, that if it is flow rate, if it is capacity the 2 meter cube or 3 meter cube per hour, according to that pump will discharge or not, discharge pressure how much it is maintained, so it is given or not. That way also you can measure the capacity of the pump or performance of the pump. So when surveyor will ask you, you first entry the question like this way. So there is a actually template, or there is a one, all the specification given in the pump manual or the template, what is pasted on the pump body, there it is written the capacity of the pump. So according to that, we are judging the pump, that how far it is given, and how the discharge is given, or how much time it is required to certain amount of the fluid for discharge. So if it is by compressing that part, by compressing that discharge of the liquid within the time which is given in the template, if it is almost equal, then it is, we can get the, we can understand the efficiency or performance of the pump is okay. But if it is not as per the maker's instruction or manual instructions, then we can assess that how much it will drop or why it is dropped. Understood my point?
Yes, sir.
Okay, Raghav understood na?
Yes, sir. Yes, sir.
Because in any pump they have actually specially asked for the centrifugal pump, but for any pump cases you can you can give this answer for the any pump. Okay, so now today I will start that your freshwater generator. So first of all, freshwater generator, just I will some picture. Can you hear this? See the picture? Raghav, Kaushik, can you see the picture?
Yes, sir.
Acha. So basically, for the onboard, why you require the freshwater generator? Why the freshwater generator concept is coming?
Fulfill the requirement of the fresh water on board, and not be dependent on the shore facility or the supply of the fresh water from outside.
Yes. So basically, because freshwater, if you want to buy the freshwater, that is also costly.
Yes,
So
it
if
will
you
be
can,
extra cost. Running cost will be
yes,
very high.
yes, exactly. So if we can produce the freshwater generator, so that is why we are use this thing basically. So on the what principle it is working?
The basic principle on which the freshwater generator produce water is Boyle's law, which explains that the boiling point is proportional to the pressure. If the pressure is higher or pressure is high, the boiling point will be high. If pressure is low, boiling point will be low of the fluid.
Yes. So basically, actually, you are reducing your freshwater generator means you are reducing your freshwater generator that air pressure, so that boiling point also reduce.
Drops.
So by boiling point dropping of the freshwater generator, but actually basically normally your boiling temperature is 100 degree,
Yes.
right? So basically why we are doing this thing? So basically we are doing this thing because we are not getting the 100-degree temperature in your actually hitting that outlet temperature, that heating outlet temperature which is going to your freshwater generator, because that is actually your outlet temperature that I am hitting from the jacket outlet, that is going to your freshwater generator, then it is cool down and then it is back to your again your tank or circulation. So basically we are not getting the 100-degree temperature. So for that reason we have to reduce the boiling pressure, right?
Yes, sir.
Means boiling temperature which is 100 degrees, so we are reduce it up to around 80 degree or maybe 84 or 85 degree. So now the thing is that how you can reduce this and what is the principle that how you can reduce the pressure, how you are creating the vacuum.
Through reductor
The
pump
base
or through a reductor. Through a Bernoulli's theorem explains, as per the Bernoulli's principle, the reductor works, and through a seawater pump, we can eject the water, and the same pump can be used for a feed.
yes. So basically your eductor pump means there is actually here also one question there is actually there is a what is the eductor pump and what is the ejector pump? What is the difference between an ejector and eductor?
Reductor Ejector pump is basically where we use equipment like ejectors, or ejector could be anything which ejects. Doesn't is not important that there should be a ejector then.
No, actually, if you can see that eductor and ejector, that there is a motive fluid. You see, this is the airline ejector. Okay, so here there is a motive fluid. So this motive fluid, when it is passes this, the cross-sectional area of this converging diverging nozzle, that time there will be actually you see there is a pressure drop, means there is a cross-sectional area will be reducing due to the reduction of your cross-sectional area. There is where suddenly vacuum is created. So this vacuum when it is created, that is passing to the outlet. So for the air and brine ejector, there is a motive fluid is your liquid actually. Liquid means your water. Because if you can see this freshwater generator, how we are using, means how the air ejector is on what liquid we are using the air ejector.
Seawater.
Correct. So basically
What?
here the motive fluid is your,
Motive fluid is seawater.
yes, motive fluid is of water. But in case of your ejector, the motive fluid will be different. That is the main basic principle. There will be, it will be steam or your air, but here it is your actually water. That is the your ejector. This is the basic principle, means basic difference.
Ejectors requires motive fluid, which could be anything. Motive fluid,
Yes.
only seawater or water, any fluid.
Yeah, ejector actually your basically it is for any fluid, especially you maybe steam or your maybe your air, that can be done. But for the ejector, you have to the this is motive fluid will be water
For ejector,
for ejector.
motive fluid will be water, either seawater or fresh water.
Either seawater or fresh water, any type. Acha. 1 minute. See, here is a written one thing. The motive medium in the ejector pump is air or steam. This is actually it is in the air or steam, but just the opposite. Just one.
Sir, we cannot take the screenshot of that.
Just one.
Yeah.
Just one. See, here is the actually your uh, this is your ejector pump, no? So here the motive fluid will be given your this thing. You see from the seawater pump that is going to your overboard. So ejector is your water, and the air is your drawn from the chamber actually. You see this line, this dotted line from the air ejector and the brine ejector.
No, sir, the another slide you shown, no?
Yeah, another slide I will show that one. This one, no?
No, no, sir. There it is written difference between ejector and ejector. Yes, sir. Just unzoom it, unzoom, so we can be complete. Yeah, but okay, sir. Okay, sir. Thank you.
Okay.
Thank you. Done.
Really, here it is little bit different, but
Yeah, sir. It's written different.
yes. So that's why don't copy this one.
Okay.
There is
So
something different. I will send
it's
it.
opposite written.
Yes, yes. Here it is written opposite. Actually, from your this page, no, from this is here whatever your freshwater generator. From here, your air ejector is the motive fluid that is you have taken it from your water to liquid. So liquid is your motive fluid. So in case of the eductor, that is your eductor case. In case of suppose if you can see the sewage here discharge of sewage tank. So there we are using the fire and GS pump. There we are using the fire and GS pump. So by using the fire and GS pump, you are using throughout the you are throwing out that sewage tank. Means you are make empty that sewage tank actually.
For soot collection tank, mostly we have. Otherwise, we have a discharge pump for soot cover.
Yeah. Yes. Otherwise we have the discharge pump. Otherwise we have the discharge pump.
But sir, still
So
I have a doubt. We mostly say air ejector for turbines or our condenser, vacuum condenser. We
yes,
say
yes,
it's a air ejector. And where is the ejector? The motive fluid is steam,
yes.
but we call it
Uh,
ejector.
that
There should be ejector.
actually your this for the steam driven pump or the this is your steam line, whatever your steam line, that is your that ejector, what we will call that is, yes, motive fluid is your gas actually, that is steam. Correct.
Steam. So
Yes.
it should be called as ejector then. But
This
and we are saying this freshwater generator. It's a we
hmm,
call it ejector pump.
ejector pump, yes.
But that equipment we call it ejector, not ejector. Ejector is choke. Orifice of the ejector is choke. We use the terminology like that.
No,
And
that is your yes, this thing is your actually your ejection is there. Suppose for your ejector pump, that ejector pump is your, this is, it is creating the vacuum. So the vacuum, how it is created, actually that is creating by your, this
ejector.
is venturi, that is, yes, that is the ejector, by using the ejector.
But you are saying motive fluid of the ejector is air or steam.
Yeah, no, that is for the ejector, you are right, that is for the ejector. For that, yeah, actually this is the ejection. The ejector is here, we are using the ejector, that ejector motive fluid is your water correct, that is the water is your ejector. Here
Yeah,
whatever we are using the ejector, that ejector part, that is we are using the motive fluid is your water actually.
yeah. So but that slide
And
was right.
yes, exactly, you are telling correct.
Motive
By
fluid is
mistake I have,
okay.
yes, that is, yes.
Because mostly because I do remember we call it air ejector, and where the motive fluid is steam, so
Yes,
should be
exactly,
ejector.
correct.
And we
Actually, there is a your air or this this your eductor is there, means yes, freshwater generator, that is actually your eductor. The pump is ejector, but the mechanism of the
it's
process,
called
that is your
ejector.
eductor.
Yes,
Yes,
we usually call ejector pump, but we use
yes,
the equipment which is called we usually call it ejector.
eductor, right,
Yes,
correct.
no, I got it.
Got it, right, exactly. Oh, okay, this one.
Okay, sir, fine. I have also corrected in my note.
Yeah. Okay. Now one thing is for the freshwater generator. Mostly, what are the process I want to discuss, that is all. No, but still one time, the how the whole process, how it is means how the whole process is going on.
Shall I try or Kaushik want to try?
Kaushik, you can tell.
What, sir?
Just describe the full process. How this complete process is going on.
Okay, sir. So in freshwater generator, we are first of all we discussed that we are thus by creating the vacuum, we lowering the boiling temperature of water. So here we are using this jacket temperature as a heating medium, jacket water, and sea water we use for the producing of the fresh water.
Yes.
Where seawater passes through the evaporator chamber,
Yes.
and it is evaporated and passes through the demister and going to the condensation chamber.
Yes.
Okay. And one more thing, sir, this seawater is using as a cooling medium from the condensation chamber, and feed of the evaporator chamber which we tapping from the outlet of the condensation chamber pipe and give feed to the evaporator chamber, seawater feed line.
Yes.
And we use the distillate pump
Yes.
take out the distillate water and supply to the through solenometer we supply to the reserve tank.
Yes. Exactly. So now one question I have, that how your that salt, how you remove the salt from the freshwater tank?
How we remove the salt?
Yes.
There's a brain ejector is there. We were taking this from this bottom sediments through the ejector, brain ejector.
No, that seawater, you are actually seawater to freshwater, right?
Yes, sir.
Hmm? So how
Yes,
you
sir.
make remove the salt? Means seawater, the salinity actually, how you can remove that salinity?
Mm,
Continuous evaporation is taking place and the brine is getting separated. So only pure vapors are going to the demisters and the pure vapor doesn't have any salt or any EDS. So this brine, concentrated brine is getting ejected continuously from the bottom of this freshwater generator.
So basically you are actually
Boiling. Actually, we are boiling.
yes, actually you are boiling. The boiling that your seawater, that boiling, after boiling your seawater, you are getting your freshwater. So you completely eliminate your salinity, and then you can go to your, so the temperature it goes to your condenser where you get your freshwater freshwater the production is there. So now the question is that how you can understand, suppose you are starting your freshwater generator. So what are the steps you should, how you start your freshwater generator? You just one time review and revise. You can how you would just start your freshwater.
We
sir,
cannot hear
not
you. You are not audible.
sir, not audible, sir.
How I am telling the how you will start your freshwater generator.
Yeah, okay, sir. Uh, we have to make sure there's supply of seawater is there
Yes.
through reductor condenser also. So we have to start freshwater generator. Before we
Mm.
start freshwater generator, we have to start the supply of fresh seawater by starting our ejector pump.
Mm.
Once
Yes.
we are getting a proper vacuum, which is
Mm.
almost around minus 60 of uh, 60 mm of mercury gauge.
Yes. Okay.
Once we are reaching at that moment, at the
Mm.
vacuum, the proper vacuum is reached, then
Mm.
we have to start, uh, and we are making sure that feed is on always
Mm.
during this
Mm.
process, and all the brine is getting ejected, proper vacuum is maintained, and
Mm.
that time we will not get the shell temperature. So now we have to start adapt the heat
Mm.
by slowly operating inlet and outlet wall of the
Mm.
jacket water to the heater.
Mm.
I gradually increasing the shell temperature, which is reaching around 40 degrees to 45 degrees, which is
Mm.
depends upon maker to maker. It could be a
Mm.
little bit higher or low, but averagely the temperature of 45 degrees is good enough to maintain the boiling, continuous boiling. As
Okay.
once
Yes.
all the valves are open, we have to shut the bypass valve.
Hmm.
We have to maintain a controlled temperature in jacket water also for the main
Yes.
engine. A proper maintain temperature, and the controller has to work to maintain a
Hmm.
proper stagnant temperature or uniform temperature to the main engine also, because this is the time when the temperature fluctuates and jacket temperatures fall down or reaches up to uh, lower jacket temperature alarms or higher temperatures alarms. So we have to maintain both the things. I mean both the temperature in the shell also, and for the main engine also. Once
Yes.
as the feed is
Exactly.
already tank is open, we have to maintain the feed. We can rise
Hmm.
or increase as per the demand. And
Yes.
once the vacuum is completed, and we can clearly see the distillate water, which is coming through the condenser through a gauge, a side glass that completely ample enough to gives good suction or prime the distillate pump. In that condition, we can open slowly opens the distillate valve inlet and outlet through the flow meter. We can start the distillate pump. Uh, Initially, the salinity will be high, so the salinometer will already bypass the initial high salinity water to the brine itself, and the
Yes.
solenoid valve will open as per high salinity alarm, and the initial high salinity water will go to the mixed to the brine, and it will go overboard. Once the salinity will come down, the salinometer will shut off the supply, and the solenoid valve will shut down, and the water will passes through, the distillate water will passes through the flow meter, and it will transfer to the reservoir.
Okay. As here, just one thing. Remember, whenever if you tell in front of surveyor will ask you that regarding the vacuum, tell that we are maintaining around the 90 to 95% or 98% vacuum.
90% it
Yeah.
will gauge, it will be 90%, but as per HG gauge, HG meter will be almost 60 to 70, between 60 to 70.
Yeah. Between 60 to 70. Don't it is make it in secondary if second option. If
Yeah.
primary option, you tell him to the 90 to 95%.
One thing
Because
also
ah
important, we have to maintain
yes,
the vacuum. We have to break the vacuum. Sometimes it's going more than
yes,
than the maker's limit, because it can affect the ceiling range of freshwater generator.
yes, yes, of course. As one thing, just remember when you before all this thing, the before starting the freshwater generator, make sure your vacuum breaker should be closed.
Yeah,
Because once you are stop the freshwater generator, you are open your vacuum breaker. So make sure the before starting your freshwater generator, vacuum breaker should be closed complete. Hmm. So that there will be air should not come. This is the first step actually. Then you start these all the steps which you are telling, and finally you uh, that the distillate pump before starting the distillate pump, that once your salinometer is okay, it's showing the salinity of the freshwater generator is okay, then you check all the valves of your pump, all the tanks, and you keep on means start your then start your distillate pump. But before that also you have to cross check practically the water it whatever it is showing or in ppm, that water by testing the condition of the water, that is also you have to check. And practically suppose your salinometer is not functioning properly, it is
yeah,
showing the
yeah.
wrong thing.
Some many
So
times it malfunctions.
yes, so practically before sending to the any tank you have to check this thing. Hmm. Then you start your distillate pump or
And
you can
I have also found that
hmm.
we have to proper line evaporator side. All the walls should be open. We have to line up
Yes,
first. That I also forgot to tell.
yes, your portal line also
And
you should open.
dosing also.
Yes, after that you
Dosing
have
has to be started.
keep the dosing on.
On.
Acha, here one question they will ask sometimes, that dosing whatever you are given, that what is the limit of the dosing, how you can dose it.
Dosing is as per the maker, sir. It depends on the production.
Yes, yes, exactly. the first thing you tell the set dosing, actually it will done from the manual or
Recommendation.
yes. As per the manual or make a recommendation, we have to done dosing. But even though if they are asking that how, but as per the how much the dosing you have done, that what is the quantity, so you can tell that approximately we can done that 50 or 100 ml per means per day 24 hours. So depending upon that, then we have to check the condition of your your tubes. Depending the condition of your tubes, then you can, if you want to increase, you can increase, or if you want to decrease, you can decrease. And even after they're asking that, then still what is the your quantity limit. And now the question is why you are giving the dosing, why you are doing the dosing.
Sir, actually, the chemical which we are using have anti-scaling and anti-foaming capabilities. Just to prevent the evaporator from the scaling and fast
Yes,
scale formation, we are using anti-foaming or anti-scaling chemical.
anti-forming and anti-scaling, correct. uh, uh. This basically the scale formation in freshwater reactor can be controlled and minimized by the continuous chemical that
Sir,
polysulfate
you are not audible, sir. You are not audible, sir.
basically your scale formation in the freshwater generator can be controlled and minimized by your continuous chemical treatment. That what actually what type of chemical you are using, that is the
Sodium,
name.
sodium polysulfate.
Yes, polysulfate compound like sodium polysulfate antifoam preferred by many engineers and said that is actually their trade name is your that Haprit or amyl oil chemical. Amyl oil Haprit is your uniter. This is the scale formation. Now one thing that on what principle this inductor actually working. This is actually sometimes they will ask that small thing. But
Bernoulli's theorem, sir.
yeah, Bernoulli's theorem. How this Bernoulli's theorem works?
Whenever the motive fluids passes through divergent and convergent shapes of nozzle, it will
Yes,
create a vacuum at the perpendicular direction of the nozzle. And because the change in the velocity and the volume, a vacuum will be created at the perpendicular direction of this nozzle.
but why the velocity of changing? There is a change in the velocity.
Because of the convergent and divergent diffusers.
Yes, the actually the construction of the diffuser. You see this one that there is a diffuser. The construction of the nozzle. It is actually the cross-sectional area of your convergent nozzle or divergent nozzle. It will be different. You see the inlet of nozzle of the converging that is towards the center. But the throw actually this is the cross-sectional area. It will be slowly. It will decrease. And in divergent or outlet of the diffuser, it will be slowly. It will
Increase.
increase. So for that reason, actually there is a difference of the velocities actually. So velocity it will be drop and then the vacuum is created inside. Okay. And to create fulfill that that vacuum, the air or liquid or other liquid it will be coming. Acha. Now the troubleshooting. What are the problems that can happen in your freshwater generator?
A lot of problems, sir.
Uh,
Less production, low vacuum, improper condenser heating, cooling, and
yes,
loss of distillate pump suction,
yes,
vacuum drop. I mean, vacuum pump is not. Vacuum is not getting created. This nozzle inductor is choke.
yes. Suppose
And supply
for
feed water supply is not in proper. Nozzle is choke. Orifice is choke.
yes, or if it's choke. So there is a production. The suppose there is a one question. This is also sometimes asked this question their freshwater generator production having the 30 ton of the freshwater generator capacity, but the freshwater generator is produced all the 15 ton or 16 ton. The 30 ton freshwater generator, it is producing the 15 ton or 16 ton. So what could be the reasons?
Improper vacuum, improper feed,
Improper vacuum, improper feed.
supply,
So,
scaling.
so scaling, okay. After scaling, okay. So if there will be scaling, so first of all, you go like this way. Let's see that main there is the principle of your freshwater generator by taking freshwater from the sea is the vacuum. So who is creating the vacuum? Ejector pump is creating the vacuum. So the ejector pump pressure, it should be actually 3.5 to 3.9 bar or approx 4 bar actually. And in some ship, if it is a good pressure, good capacity ejector pump, that it can show your 4.5 or 4.6 bar pressure also. So this pressure, even if you can drop there, drop the pressure, so then the vacuum will be dropped. To core your main problem in your ejector pump. First, your troubleshoot when you are going for troubleshoot, just check the vacuum pump pressure, your ejector pump pressure, how much, whether it is given the proper pressure or not. Now, if you see the ejector pump pressure is okay, then where you are coming, what parameter?
Shell temperature.
Now, ejector pump pressure is okay, but still your vacuum is not coming 95%
Okay.
or 90%.
Regarding vacuum only you are asking.
Yeah.
Okay. If ejector pump pressure is okay, then we have to check ejector nozzle,
Ejector nozzle or what else?
check valve.
No,
Check.
not check valve. Okay, check valve after that, before small part, small thing.
Any vent is open or something.
Yes, maybe your vacuum breaker is open or
Vacuum is
it is
open
leaking.
because of the seal gasket.
Yes, seal gasket or your gauge glass or your gauge.
Gauge glass is broken. Yeah.
Huh? Or if it is vertical type boiler, vertical type freshwater generator, the top cover where is the gasket is there, from the
Gasket is there.
gasket there is leaking. So these are the means practical aspect. This is you can small thing, from that also air can be leak can possible. Even though if this all these are okay, so that time you can go to your ejector part. Maybe the ejector there is a anything got stuck or something passing something solid part or solid portion, it is get stuck, so that there is a creating the it get obstruction for getting creating for sucking your vacuum. Or then you can check your fit check valve, that is also. So this is the part, means these are the parts you have to check for the vacuum aspect. Now if it is vacuum it's okay, then still it is taking the less, it is giving the less production.
Then we will
Then
check hot water supply, jacket water supply. Is
then
that
you check the, yes, jacket water
shell
supply. Now
temperature is maintaining or not?
cell temperature is maintaining is, suppose your cell temperature it is very high, maybe 60, about 60 or 62 cell temperature. So what will be action here? What action you will take?
We'll shut the control the supply of sewer jacket water, and we'll check whether the feed is proper or not. Feed should
Okay.
be feed should be continuous and as per the maker's rate. How much feed we have to give? If there is no feed, shell temperature will reach very high.
So you have to check the
Also muted themselves. Sir, you have muted yourself.
so that time you have to check the feed pressure actually. So what should be your feed pressure? As per the maker's instruction, you have to check the feed pressure. So if your feed pressure is okay, then
Scaling.
Yes, exactly. So there is another option, the scaling will be there. So that time you have to check the scaling. Means you have to check your scale. You have to clean your evaporator.
Yes.
So after evaporator cleaning, you check the still the production will be less.
Mhm.
Then where you are going?
Actually, this happens with me practically. I don't know whether and it was rectified as because shell will show you vacuum, good vacuum,
Hmm.
but there is one more air ejection from the condenser also,
Yes.
which will not be shown in the gauge, which is through a
Yes.
check wall,
Yes.
and that check wall is stuck, or there is a plate which is not working properly, or throttling effect is not good, or ejection is not good. There will not be
Hmm.
vacuum in the. We need a vacuum, same vacuum or more vacuum in condenser also, other than the shell, because
Yes.
it will show in the shell, but it will not be in the vacuum. So the ejection of the air from the condenser will not go. If there will be no ejection of the air from the condenser, the
Yes.
condenser will not pull down the distillate also, and your distillate will be waste. It will come down and drop down in the brine. So that the check valve and that vacuum has to be improved.
Yeah, that's check valve and pharmacology. Yes, that is also one cause. But still also, if it is not found that your production will be there,
So
what are the another cause?
condenser has chopped. Condenser has to be cleaned.
Sir, after
Condenser
all
having
those,
the problem. But okay.
sir, one more thing. After cleaning
Ah.
all those things, evaporator and condenser chamber also, if not
Hmm.
production also increase, everything is okay.
Hmm.
Time we have to
Hmm.
check for the feed inlet temperature. What happen if we go for the cold country where temperature is 1 degree or 2 degrees water temperature? That time only
Yes.
production will automatically will drop. Whenever the seawater temperature is near about 25, 26, that time also production will increasing. It is happening last time.
Production
Yes.
will increase in cold
Whenever I
temperature.
am going to the Russia, that time
Yes.
production is dropping. When you come back to the 25 to 25 around seawater temperature, that time production is increasing by 3 to 4 ton more.
Yes. Exactly. That
Plus,
is also one part.
as per the Macker manuals, lower will
Ah.
be the seawater temperature, higher will be the production.
Thermal deviation will be there. Now you are giving the 70-degree temperature. It will more take time to come up that much temperature to boil off. So if you keep the temperature, your temperature near about,
But our feed is outlet
it
of
will
the
take.
condenser, right?
No,
Feed is,
see,
yeah,
your
he's right. Feed temperature should
yes,
be a little bit higher, but
yes,
we cannot increase the temperature. But
no. The seawater temperature you cannot increase
We
actually.
cannot, we cannot. This is not in our hand.
because it is going outside from the evaporator.
Yes,
So whatever temperature is in the evaporator, it will directly come up to 35, 40 degree.
yes, because evaporator, whatever you are getting correct, that is around your, if it is going to 25-degree temperature or 26-degree temperature, so that will boiled up and it will come to your around maybe 40 or 42, like that temperature it will come. So ultimately when it will come to condense that amount, so that amount after condensing, that temperature will maybe 2 to 3 degree it will vary. If you can see the freshwater outlet or inlet, means condenser seawater temperature, whatever, what is the difference between the seawater inlet or outlet temperature, you can find there maybe like seawater inlet to the condenser and seawater outlet to the condenser, means around, sorry, 9 to 10, no, around the 2 to 3 degree or 3 to 4 degree. Not so much deviation will be there in the condenser temperature inlet and outlet. If you can see the condenser outlet inlet temperature, so difference is not so much actually. But practically, if sometimes apart from this, these are the actually graphical or geographical uh, variation of the atmosphere. Due to that reason, there is a varying. When you go to the Russia, there will be less consumption, less production. If you come to the tropical zone, there will be little variation. If you go to the USA, then also it will. If you go to the Gulf, so due to the variation of the CO2 temperature, it will vary. But even though apart from that, there is
If we
another thing which is damaged.
Mr. Answer, if we tied the more these plates,
Yes, in plate type, if it is plate type freshwater generator, even though if a tighten or sometimes during the time of tightening procedure, that time sometimes even the gasket will be displaced from that place. So that time also there will be leak and there will be intermixing of the seawater, freshwater. That time also it can happen. And especially if you are doing the for plate type freshwater generator, that time when you are tightening your plate, that time you should be very, very careful. Whatever the distance before it was and what is the condition of your gasket, all the gaskets should be okay or not during the time of your attaching the plates. So and there especially there it will be much more effective for your skill. So if you, until and unless if you are not cleaning in the proper interval, scale for the skill removal, you will not get the proper effect, or you are not getting the proper production of your freshwater generator for the plate type. For the scale type means for the your vertical or tube type shell and tube type freshwater generator, that is for the cleaning purpose, it will be much more easier than your plate type freshwater generator maintenance part. But that what I am telling, apart from these all these geographical condition, all these things, there is the another part which is your demister, because sometimes mostly people are forget that okay, demister is okay. But if demister also it is choking, that time it is also not, the water is your vapor drop, it will not going actually to the condenser. What is the material of your this vapor, this your demister?
Sir, stainless steel.
Stainless steel, or basically it is actually monel metal actually. Yeah? It is your knitted monitor. Condenser plate is your titanium. Tubes are your aluminum brass. Shell is your fabricated steel with sheet rubber coating. Ferrous metals such as nickel. Okay.
Sir, can you reduce the size?
Hmm.
Okay, sir. Thank you.
Then another part, that is, suppose your freshwater generator, your salinity will be high. So what are the reasons for your salinity and will be high, and what will be your action?
Reduce the feed.
Reduce the feed.
Reduce the feed.
You
For the
reduce the
scaling also,
uh,
check your inlet outlet temperature of the jacket, and check the supply of seawater also in the condensers. Check for the vacuum. Vacuum, if vacuum is high, salinity will be high.
yes, salinity will be, vacuum will be, yes, vacuum also one point, correct. Then you are giving the more feed, that is also one point. Then if your heating temperature will be dropped, inlet will, suppose instead of ending it, it will be dropped to the 70 degree or 65 degree. So heating inlet temperature also it can be dropped. Then Then what else?
Yeah, sir, it is written tubes are leaking or there is
Yes.
cracks in the plates.
Yes, cracks in the plates. If
Ceiling
you're
has, ceiling is
yes,
gone.
yes,
It has gone.
yes. If it is cell type or plate type tube, then there will be, due to the gasket will be worn out, it will be broken for then there will be, or if it is tube type, there is a leakage in your tube, so CO can enter. Or you can feed increasing your feed will be less. Mm. So if you are suppose, then how you can identify what is your exact?
Sir, when there is a leakage through tubes or gaskets, the salinity will shoot very, very high. But in case of vacuum, the salinity will be moderate. It will give alarm, reach to
Yes,
alarm level, but it will be.
yes,
But in case of leakage, it will salinometer will stop showing the salinity as well. It will be that much high.
yes, yes. Because it will be suddenly, if there will be leakage, it will not take too much time. Instantly, it will raise to the higher actually. But if it is there is any other option apart from this leakage, there will be then yours that will give the minimum time actually. So you can adjust it that time. So what should be actually in that case? What will be your action? So your action, what should be your proper action you should take?
Sir, initially,
Initially, if it
the
is normal,
salinometer will
yes,
activate the solenoid and the water will, distillate water will go through the brine section. It will go to the brine.
yes, it will go to the brine.
Uh,
Otherwise, then
uh, that is one of the safety. It will not go to the distillate tank. We have to shut off the distillate pump
yes,
and we have to rectify what is the problem. Then only we should start distillate pump again. It should not mix with the reservoir tank.
yes, yes, exactly, exactly. Actually, sometimes either your sometimes it can happen. You even the feed will be more. So if the salinometer again sometimes it happens if the salinity meter it will be given the alarm salinity given the alarm and then it will given it give the salinity alarm and then it is gone. It is going on and gone and it gives the salinity alarm and then it is gone. So like that it is happened, but that is not the case of your leakage. That is in that time you have to just you can reduce the feed or you check or monitor your heating temperature. What is your heating temperature? Or even though if it is all is okay, then you check the vacuum. In case of your vacuum, what is the vacuum condition? Or if it is vacuum condition is not okay, then you can go to your centrifugal this ejector pump. What is the ejector pump pressure? And also you have to check the your shell temperature. So if this all the parameters because all are it is related actually. So main thing is that for the salinity instantly if it is going like that there is some 2 3 kinds is there. The salinity if it is going again it is within 1 2 minutes the salinity is gone again it will come. Sometimes due to rolling also it can happen. If it is too much rolling or too much very rough weather ship is going that time also it can happen. But for the surveyor purpose means for the you're going for exam so that time you can give the LVA. You have to go for step by step. You have to check the all the monitoring. You have to check all the parameters of the fresh water generator. First you have to check the vacuum. First you have to check the ejector pump pressure. Then we'll go for the vacuum and then we'll go for the salinity the feed pressure, then the heating inlet and outlet temperature. So all the parameters we have to check and monitor. Then we can go if there is any information, if any deformation or deviation, then we can adjust according to that. Or if they want more, surveyor asks to know one word answer or like that he is not satisfied, then you can tell him that we can reduce the feed little bit and we can check it and we can increase the feed heating you can increase the heating quantity means heating temperature quantity by whatever the bypass valve by adjusting the bypass valve we shutting that bypass valve we can increase the more heating liquid. More we can send the more quantity of the heating water to your evaporator, and we can little bit reduce the feed. And then we have wait for some time, and we will check that what is the salinity, it will react, or what it will give the reaction, whether it will reduce or not, and wait for the time being what result it will give. Okay, like this way you can give the answer to the surveyor. But what I am saying the practically, because practically on board ship, whenever there is a salinity or there is a vacuum drop, so all the things, all the parameters you have to check. First of all, your ejector pump from ejector pump pressure to your then vacuum drops, then heating inlet outlet temperature, then your feed pressure. So this thing, all the things you have to check, and you have to monitor from your regular whatever the parameters, how much you are giving the limit. So from that you have to comparison, and then you can identify. Okay, so this is understood, no? Is how you can give the answer to the surveyor if they are asking this type of troubleshooting. Normally from the freshwater generator, whatever I have seen, they will ask either this type of question that your capacity of the freshwater generator is reduced. What is your action, or what could be the reasons? Okay, or your salinity, like this question, like this, your salinity will be high, what will be your action? Your vacuum will be dropped, what will be your action? And mostly what principle freshwater generator works, or your ejector, what is the difference between the ejector and ejector? So these are the materials, these 4 5 things they will ask. Okay, so up to this okay na, freshwater generator?
Yes, sir.
Yes, sir.
Okay. Acha, okay, any people you have work in RO plant? What is the, so this is a small thing. What is the difference between the reverse osmosis and osmosis? Just give the brief idea, so I can tomorrow.
Then that this osmosis is a procedure where we separate the two liquid through the membranes, which is the higher density, which is the lower density. In normal osmosis procedure, this lower density liquid is tendency to flow towards the higher density liquid through the membrane. It is a procedure called osmosis. In that reverse osmosis, what we are doing, we are uh, flow of liquid from the higher density to the lower density side through the member with the applying the external pressure or pump.
Correct, exactly. Actually, if you go to your normally product tanker, or this thing, your chemical tanker, there you can find the RO plant actually. So they are the same thing what Kaushik said, that so you are sending the higher concentration to lower concentration through the high pressure pump. Actually, there your this Schwarz plate type pump is there actually. So high pressure pump is there. So by high pressure, applying that high pressure pump through the membrane, two types of membrane will be there. That is very fine membrane actually. So through the membrane, they will send the seawater. So this conversion through the membrane, that seawater is making the fresh water. So I'll just discuss with this tomorrow. So that is actually your RO plant, And normally this RO plant basically for your take purpose they are using for product tanker or chemical tanker. If you have worked with product tanker, chemical tanker,
Sir, I am working with chemical tanker.
chemical tanker. So that means you know that you have already know this that RO plant. I think you have on board the RO plant. You got it, no RO plant.
No, sir. Still now I didn't get any RO plant. For the
Oh,
tank cleaning purpose, I have the two fresh water generator. But that one
oh,
also one is working with the steam, one is
hmm.
working with the jacket water. So while standstill condition also we can start the fresh water generator, the steam. I did one shift like that.
Acha, acha, acha.
I have not worked on Arrow plant, but I have installed because we were in the modification of from tanker to FPSO. That time I have installed, but I have not used it.
Acha, acha, okay. There is a same actually. The thing is that only you are using the membranes.
Yes.
The membrane and a high pressure pump you are using, but remaining is the same. That seawater is passing through your high pressure pump. Then the high pressure pump it send it to the all the membrane. There is two stages. It depend upon the manufacturer. So that membrane will be utilized your making this salt water to seawater to the fresh water. And basically, some ship it depend the manufacturer. If it's Japanese built ship, they are using the dedicated RO plant for the making the water to your washing of the take tanks. But in Korean build, that will be different. So made to made means Japanese made it will different. Korean made it will be made different. So this is the RO plant. So RO plant tomorrow I will discuss. So up to this freshwater generator, this up to this it is okay, na?
Yes, sir. One sir question
Hmm.
regarding the pumps.
Hmm.
We have covered most of the topic, but there is a question: the
Hmm.
parallel and series operation of the pump.
Hmm.
Why we are doing this parallel
Hmm.
and series operation of the pump?
Acha, okay. This is I will show you one thing. Forget to. This is the parallel operation. Parallel operation increases volumetric flow without increasing the head. See, this is basically you are using the pump when you need the much more volume or capacity of the pump is required. Where you need the volume means a high flow of discharge. High flow of discharge when you need the high flow of discharge. That time you need this pump capacity means this type of pump parallel. If you are putting the impeller in the parallelly, then you can use this pump. You see, the impeller it can see actually that in sometimes you see that the two-stage impeller, two impeller is given into the your same pump shaft centrifugal pump. Two impeller is given, so that means you are given the more volume of more discharge you are given in case of parallel operation. We don't need the head actually. Understood?
Yes, sir. Two impeller. Otherwise, sir, we are for the
Multi-stage pump.
yes.
Yes.
One more thing, this for seawater for LD cooler
Hmm.
supplying. We sometimes we start the two seawater pump
Hmm.
in
Hmm.
the parallel condition, and that
Yes.
series condition we have the for supplying fuel supplying booster
Yes.
pump and that supply pump that is connected in the series. So that time where record we pressure, that time we record the series.
Exactly. Or
Okay.
record your pressure, you can get the series pump. That is actually if they want to ask, you can give the reference of this means graphical representation you can give him. That in case of your parallel operation, where you need the capacity, or this one is in series condition, this increases the head without increasing the volumetric flow rate. So this is the basic thing, that where need the pressure you can use in series, or where you need the multi-stage, or where you need your volumetric discharge, there you can use it. That is the basic two difference. Okay.
Okay, sir. Dear.
Acha, so for today it's okay. Tomorrow I will complete your this thing. This is your, what is called, this is your RO plant and your plate type heat exchanger or tube type heat exchanger and valves. Okay. Tomorrow is your Friday, na? Tomorrow is your Friday. Friday now, Saturday tomorrow. Tomorrow what day? Tomorrow is Saturday, na?
Saturday, sir.
Saturday, okay. So okay, so tomorrow I will complete your this topic, and we'll just discuss the whatever the remaining questions they will ask from your, because freshwater generator asking there this much question they will ask. You can see the question, this question they will maximum to maximum this type of question they will ask you, freshwater generator. And okay, pumps is completed, so freshwater generator completed. So okay, so up to this is any doubts or anything, any questions regarding the freshwater generator?
Not regarding the freshwater generator, but still I have doubt regarding swash plate pump, radial flow, and axial flow. Swash plate or variable delivery.
अच्छा, swash fluid pump or valuable delivery. Okay.
The
अच्छा,
axial flow type and radial flow type.
axial flow type and radial flow type, na? Okay, okay. So this axial flow type, or first of all that I will just okay, then what is the variable delivery pump and what is the fixed flow control pump or your fixed flow type pump?
Here the discharge rate or discharge capacity we can vary.
Discharge capacity we can vary. Now how we can vary the discharge capacity?
As you shown yesterday, we can have a eccentric pump or the eccentric shaft type pump.
Actually, if you can, this one, you see, by varying the displacement, actually we are vary the displacement or output of the pump, delivery of the pump. That the displacement is your formula is pi r square L. So here, if you can see, we are changing the swash plate angle. This is your swash plate. This side is the stroke length is L, and this is the angle. One minute, show another picture. This 0 degree to x degree. You see here, 0 degree to x degree.
Yes, sir.
So by varying the 0 degree to x degree, this length, actually this L will be varies. The which how much it can push inside the cylinder, inside your cylinder, how much piston can push inside, or how much it can come out, how much it can get out, how much it can get in. So this stroke length will be vary by the angle, the 0 degree to x degree, by the angle changing of the angle of your piston. So when this will be vary, displacement will be vary, the flow rate of the pump will be vary. Flow rate is equal to displacement into RPM divided by 230. That is the way of displacement or delivery can be varied. But for the case of your fixed flow pump, either gear up or screw pump, any pump, the flow is not varied due to this angle deviation 0 to 0 degree, because once this wash plate is come to the 0 degree, there will be no discharge. If you can see in steering gear variable delivery pump, there is a 0 to 1, like this. We are giving the movement as the 0 position, that means no discharge. When it's shifting the 0 to 1, so there will be discharge. Again 0 to 1 dash, there will be discharge. Actually, like that, we are in graphically representation, we are showing like this way, right, Raghav?
Yes, sir.
So for this reason, it is showing the variable delivery. You can, up to this you can understand, clear?
Yes.
Clear na up to this?
Yes, sir.
So now the construction of your, this is your swash plate pump. The swash plate here, this side, this is, see where it is showing the X. This X, that line, this is your, this line is drawn the axis of this plate. This is actually your swash plate. Now I will show another diagram. You see here it is the swash plate. This is, it can shown. Is it visible?
Yes, sir.
So here it is showing the swash plate. Now this plate is fixed with your, actually this plate, this angle, it will be moving by your servo piston. This is, and this is also connected with your regulator. So when the angle of this plate will be changed, the displacement will be changed. Up to this you understand?
Yes, sir.
So now this construction of the pump is such that you see here it is your swash plate, there is a retaining plate, the piston inside, there is a cylinder block, this is your bearing B2, there is a pressure plate, this is your servo piston, there is a top one is your head, and this is complete is your housing, this is your regulator. Up to this clear?
Yes, sir.
Now I will go to the another part.
So now this plate is getting operated. I mean, we are displacing into the different angle.
Hmm.
How initially when the pump is not running?
Actually, see, initially when there is a pump is not running,
Pump
practically,
is
theoretically, we are saying there is no discharge.
yes, the plate is in
Means,
the straight condition.
yes, we are saying there is a no discharge, but
Yeah.
actually there will be discharge. There will be minimum discharge. Due to the minimum discharge, because why there is a minimum discharge? Because that plate having the lubrication also. So that minimum lubrication will be done. Your minimum there is the hydraulic oil action. So the minimum discharge will be required to the lubrication of the moving part of the pump, like your swash plate, there is bearing, there is a piston. So for that part, the whenever is a zero portion, means zero angle, that is also minimum discharge will be there. That is theoretically we are not saying that when the zero degree there will be not discharge, but the minimum discharge practically there will be there, happen there.
And how this plate will be displaced to the angle which how supply is going to the servo cylinder, servo pistons. to displace the disc, because it is an intact pump.
So this is actually the displacement. Actually, you like this. This is the another diagram. See, this is your same thing. Actually, that this is your inlet. This portion
Green one is the inlet and red one is the discharge.
is the discharge.
And
Because the thing is that when this is see, the piston is going inside. Okay. So when piston is going inside your cylinder, there will be volume or this place because stroke length will be increased.
yeah, so that I understood. So
Hmm.
stroke length is changed. So volume of the oil which is coming inside the piston. Okay, this is the operation for the disc.
Yes,
Okay, it's not the suction or discharge of the pump. It is the
yes,
operation
yes,
of the disc only.
yes.
Or this is the operation of for disc, or this is the pump suction or discharge, red and green.
No, this is the pump suction and discharge actually.
Pump
Because
discharge, no?
yes, yes, pump suction or discharge. Because once your this
So
piston,
how this disc is operating?
this disc is operated by your this. There is actually this part. This disc is operated by your regulator. Here,
Yes, this diagram I want to see. Well,
there, here,
from where
see.
the hydraulic oil will go inside this.
Yes, there actually there this head, no, this is your, if you can see this head, there will be another hydraulic coil which is pushing the servo cylinder. So when this servo cylinder got pushed by the hydraulic coil, it will push to this mechanical, this plate is connected with the spring. You see this swash plate is connected
Okay.
with the
I thought this green part is not
uh,
connected. Actually, this green part is the intact part of this disc. This
yes,
this arm.
yes, this arm it is
Okay.
connected with this part. Yes,
I
okay.
got
So when
confused of
this
this
part,
green color. When the
yeah,
head piston will get activated, it will
yes,
rotate. It will shift the arm, and because of
yes,
this arm, this disc will
yes,
movement of this disc will take place. So it's okay.
correct.
So it is the from outside source the oil is coming here.
Yes, yes. From outside
I mean,
source that
the
oil will come.
pump discharge, this oil is coming to the head mechanism, and from where
Yes,
we are activating this position.
yes, exactly. Exactly. And actually, your discharge, there is a pressure plate. You see this diagram. There is a one pressure plate that you can see. There is a
Sir,
bearing. You know, huh?
sir, one thing I want to ask you,
Huh?
that in the Primo operation, in the
Hmm.
cargo control room,
Hmm.
we are using this lever, we are increasing or decreasing, and
Hmm.
that
Hmm.
will connect to the potentiometer, and
Hmm.
that potentiometer actually working this for this servo cylinder. This is my question.
See, actually, this potentiometer is working. Actually, you have the manual circuit is there. Actually, it is even you can see the circuit. Then only it is understood. Actually, I don't have this that you are talking about the CCR, no, that handle your
Ah,
that
yes.
RPM, but you are
Hmm.
increasing and decreasing the thermo pump speed. Actually, if
Yes.
you basically it should connect it with the potentiometer and it should
But
work.
there will, sir, there will be
Uh,
two things is there. One is the system pressure set knob, what
yes,
pressure
yes,
200, 150, and another
yes,
is this lever for the for the particular the cargo pump. Okay, sorry, that is the for the cargo pump, and that system pressure I'm talking about.
One is your system pressure, correct? One is your system system pressure, because one pressure, that is a normal pressure, that pressure that is your circulating pressure. Another is your system pressure, that
Okay,
maybe which is 170 or 180. When it is one Framo pump is running, then it is 150 ideal pressure. If it
is
is
that
increased more than 80,
uh,
190.
is
So
that operating the servo piston?
yes, obviously, because I think that servo piston is the main purpose which can increase your pressure, because the servo piston means that otherwise there is a no option or no hydraulic, because hydraulic means there should be one servo piston or servo cylinder will be there. There should be.
Okay, sir.
There should be the servo piston that should be working or acting on the pump, and means your hydraulic oil, that then only the pressure will increase. Otherwise there is a no other thing there will be there actually. But if you have any manual, because I was also searching but I don't get this type of manual. If you have, you can send me. If you have this that CCR controller, means what is the mechanism and this is the circuit, that is how it is transferring that diagram, actually means how it is connected with the CCR, that system. You have that manual, Raghav? Ye Kaushik?
Sir, I'll search. I think I have this FAMO manual.
Manual have, no? Can you please post it in the group?
Okay, sir. I will search. Because one
Oh,
time, one friend, sir, because of this question, one time, what happened? The system pressure is not increasing. Everything is
hmm,
okay.
hmm,
Leakage is there,
hmm,
nothing is there.
hmm, hmm,
So, Batisa was to check the further potentiometer. He is saying that the signal is not coming. Whatever is the giving signal, it is not
hmm,
coming to
hmm,
the potentiometer, which will operate the Framo pump.
hmm,
So,
hmm, hmm. It can, yes, because
so
normally potentiometer is there. Actually, potentiometer
because
it is,
Raghav is
yes.
just now he asked this, how does this servo cylinders work? So
Mhm.
that time it recalled me that I think that is that way this cylinder is working. Okay.
No, actually that isn't, because you have to know. I mean, that circuit, no, that hydraulic total diagram you have to know. Then you can describe, or you can identify. Means you can, then you can explain actually. Otherwise you cannot. You cannot understand also. That diagram is required, hydraulic diagram, how it is connected and what is the mechanism it is going on inside. Okay. So because I am also searching, but I don't get this manual, that circuit actually. Okay, so if you can have this, you can please share it to the group. Huh?
Yes.
So yeah, this Raghav, now you understand what is your queries, means what is your doubt.
Sir, can you show the complete figure? Because I want to know.
Hmm.
So where is the oil discharge now?
Actually, no, this is complete figure. This hydraulic figure, I maximum to maximum, I can show you this thing. Okay.
Okay, so from the last slide, no problem. Okay.
Last,
First figure is
this,
for pump suction discharge. Okay.
yeah,
And another figure was for this is pump suction and discharge,
yes,
right?
yes, exactly. Actually, no, that I'll show you another thing here. Actually, there is a one normal pressure plate is there. So this pressure plate, there will be suction and discharge will be there. So that suction and discharge, there will be this is okay,
So
just
suction
one.
and discharge will take place inside the cylinder only, right? Cylinder block.
Yes, yes, inside cylinder block there is a pressure plate. So through that pressure plate it will going. Actually, I don't have this much of your means complete this thing. See, this is your source plate, this is your casing, this is your regulator, hmm, and this is your shaft bar, shaft block. This is the piston. This your head. Actually, this is the place. No, this you see there is a one circular portion in the head. This is your actually pressure plate. this side. In the head, there is a one circular portion. Inside in our circular portion, there is a small one, that is big hole is there. Can you see this hole?
Yes, yes, yes.
This is actually your suction part.
Yeah, this is section part because this arrangement is in the side. I have seen with the piston.
Yes. And this opposite side, this three portion, there is a three small hole is there. That is your discharge part.
Discharge part. This is the cylinder block.
Yes.
Inside
This is the head actually.
head.
Okay.
And
This is
yes,
your
this will go inside. This you just
yes.
the piston assembly.
Yes. Exactly. This
And
will go
now
and see this.
this
This is
one,
your
you have
yes. This is
pistons
your
are
shaft. This is your block plus piston.
blocked.
This one.
Okay.
So this one connected with your head. This one connected with your head. You see this diagram now. This is your cylinder block where your piston is connected.
Yes.
Huh?
Yes.
And this is your swash plate this side. The
This
swash
is
plate is
flash
this.
plate. Yes, this
Huh?
is flash plate.
Swash plate. And this regulator is your this one diagram in picture. This is your regulator. This top part actually. And there is the servo piston.
Yes, I got it, sir.
Hmm?
Got it.
So actually this pressure plate having your actually discharge will be this side actually. That diagram is showing means
Yes.
in the diagram is showing that side actually. So but in through the pressure plate it will delivery will be there. Means discharge and suction will be there.
Yeah, from this section. Okay. And
Okay.
this will operate inside this. And the
Yes.
three ports are the suction port, and the big
Yes.
one is the discharge port.
No.
No, big one is the suction port, and three parts are the discharge.
Yes. Discharge port.
Okay, so got it.
Okay.
Thank you, sir.
So okay, now it's clear, no? Okay. Okay then. Okay, so tomorrow I will take this class. This is 3 to 4. So tomorrow I will complete your this RO plan and your cooler and the valve accessories, that part.
Okay, sir.
Okay.
Okay.
Oh,
Thank you.
thank you.